Okay, so we're looking at solving systems of equations. We're going to start by reviewing the two variable systems. Do you guys remember doing those previously? Two variable systems?
Yes.
Some yes, some no? Okay. All right, so for the first one, and this exploration is printed out for you, but I want you to look at the systems and match them with the graphs below. So here we go. So the system for little a goes with which graph?
Big B.
Goes with big B. Yes, big B. Okay. How did we get to that conclusion? What did you do? Okay. So did you put both equations into slope-intercept form? Okay. Put both equations into slope-intercept form. We see the slopes are the same. So therefore that matches with this one here, which means what kind of lines do we have?
Parallel.
They're parallel, and if you have two parallel lines, can they have a solution? No, they never ever intersect. So this is a no solution. Therefore, this is inconsistent.
Wait, why is it inconsistent? That's no solution.
Because there's no solution to it.
Parallel line. Why do parallel lines do
They never ever intersect. Okay, so remember, whenever you're solving a system, you are trying to find that one common place that satisfies the equations. And so if they're parallel to one another, they will never touch. So no way to ever find a solution. Okay, little b goes with which graph? Big C. Okay, so again, if you put it into slope-intercept form, we see that we get one positive solution, or one positive slope, one negative slope that only matches C. What is the solution to C? It's 3, 1. And this is consistent.
Yay.
Okay, that leaves the final one. System C, little c goes with the graph of big A. And again, if you put those both into slope-intercept form, we find that they are the same line. How many solutions would that system give us? It's not all. Well, it is infinite solutions.
All real solutions?
Well, no, the only solutions we have to satisfy the line, but the line goes on forever, so we have infinite solutions, right? So if I tried to say, we can't say all solutions, because if I pick this point here, is that a solution to the system? No, it's not. It has to satisfy the equation of the line, but the line goes on forever.
Is that consistent?
It's consistent.
It's only inconsistent if there are no intersections anywhere.
Yeah, if you can't get a solution. Okay. So let's look at, yes?
I'm a little confused on how the inconsistent and no solution and inconsistent.
Okay, well, so it's because you can't get a solution for parallel lines. And so therefore it's an inconsistent system, just because there's no way to ever find a solution.
Okay, and then, but for A, is it just infinite solutions because they're the same line?
It's the same line, yeah.
And then the other one is just one intersection?
Only one. This is the only solution for this system. Okay, so if you recall, there's a couple different ways to solve systems. For a two-variable system, you can graph, but you can also use substitution and elimination, because sometimes graphing takes a little bit long. So you kind of always step back and you look at the entire system to make a decision as to which method you want to use. So in the first one, I notice already that I have a positive 1y and a negative 1y. which means if I add these two together, if I get 2x plus 1x, that's 3x. What happens to the y's?
They disappear.
Or they have been eliminated. We've just eliminated them. And I add my 5 plus 1, that's 6, which means what does x equal?
That is way easier. That is so fun.
All right.
Wow. That's like,
I love them. They're so
Okay.
satisfying.
Yes. So I found x now. How do I find y?
You plug
You
it
plug
in.
it back
You
in.
plug it back in. Which equation do you want to plug it into?
Second one.
Probably the second one. It looks a little bit easier.
Yeah.
So we get 2 minus y is equal to 1, or y is equal to 1. So the solution is the ordered pair, 2, 1. It's graphed for us. Does that match our graph?
Yeah.
Yes. That's that point right there.
Y is equal to -1? No, just kidding.
See it? Okay. All right. How about in the second one? Do you see something we could easily eliminate?
Yeah. The x's.
The x's again, not again, the y's previously. So this one, I add those, that's gone. 3y plus 2y,
5y.
5y is equal to 4 plus 1 is 5, which means this y is equal to 1. And again, I want to solve for x. Which one do you want to plug it into?
First one.
First one. So we get x plus 3 times 1 is 3 is equal to 1. So x is equal to -2. So what is the solution to this system? -2, 1. Again, an ordered pair. And does that again match our graph?
Yes.
Okay.
And it's satisfying.
All right. So for our last one, why don't we just go ahead and do substitution since we haven't done a substitution yet? Which variable do you want to isolate, x or y?
X.
You want to isolate x. Okay, do you want to isolate x in the first equation or the second equation? Definitely the first. Okay, so in doing that one, let me get a... Alrighty, so I'm going to take this here. I'm going to isolate x. X is equal to -y. And then I'm going to plug that -y in for the x in the second equation. So 3 times -y plus 2y is equal to 1. This gives us -3y plus 2y is equal to 1. So that means -y equals 1, or y is equal to -1. Okay, so once yes, now we're going to plug it back in. So what does x equal?
1.
1, because x is equal to -1, which is +1. And again, the solution is the ordered pair, 1, -1, and does that match our graph?
Yes.
So there we go. Okay, so are these systems coming back to you?
Yes.
Yes? Okay, yes, Carrot.
Is it okay? You did x equals -y. Is it okay that I did y equals -x?
Sure is. Okay, so I want to get into some application problems here. And these should be printed for you. Oh, these should be on that small sheet for you, so you don't have to write everything.
Oh, yeah.
Alrighty. So we've got movie tickets that cost $6 for adults and $2 for children under 12. I would love to know what theater that is. I don't know any theater that has tickets for that cheap.
Yeah, that's nice.
Yeah. If 175 tickets were sold with cash receipts of $750, how many of each type of ticket were sold? What is our unknown here?
How many?
How many adult and children tickets were sold? Okay, so I usually like to match my variables to whatever term is inside my application problem. So I'm going to go ahead and say I'm going to let A equal the number of adult tickets. So what am I going to call my children tickets? C. C is equal to number of. I love the enthusiasm this morning.
Stop.
Y'all were actually more like a Friday this morning than a
I
Thursday.
guess it's our Thursday.
Thursday's my favorite day of the week.
It's a Friday for us.
Okay, so how many unknowns do we have here? 2. So the rule is for every unknown variable, you have to have one equation. So if we have 2 unknowns, we have to have 2 equations. So now we've got to go back into the text and figure out where can we get 2 equations. So what are some of the things that stand out?
175.
175 represents the total tickets. So then what equation would that give us?
C plus A equals 175.
Okay.
Yes.
C.
Wow.
All right. We need one more equation. What else can we come up with?
I know. It's fine. Sure, no. Is it 6A plus 2C equals 750? No.
Yes. Or since I'm at the C first, I'm going to repeat the C first. So 2C plus 6A equals... Oh, they mean the same thing. Okay. Do we now have a 2-variable system?
Yes.
Okay. So whenever you are setting up your equations, you always want to make sure that whatever you have on the left-hand side, whatever unit you have on the left, matches the unit on the right. Okay? So our first equation, the unit on the right is 175 tickets. Does C and A represent number of tickets? Okay, that's the unit. Okay, the second equation on the right is $750. If we were to multiply out what we have on the left side, does it give us the units dollars? $2 times C plus $6 times A.
Yeah.
Those are dollars. Okay, so you always want to make sure those match. So now we have our 2-variable system, and we can solve it in either substitution or elimination. You guys pick. How do you want to do it? Elimination.
Eliminate.
Okay. Alrighty. What would be, which variable would be easier to eliminate? The C. Okay. So whenever you're eliminating, you look for the variable and the coefficient that's going to have like the least common multiple. So C is going to be it. So I need to multiply C by what? -2. All right, so I'm going to do -2 times the first equation.
Oh, because you're trying to you're trying to make it this, so that you can cancel.
Yes, so I can cancel. Okay.
Sorry, that took me a while.
All right, so I'm going to do, let me move it up here. -2C, you have to multiply everything. -2C minus 2A is equal to -350. And to that, I'm going to add 2C plus 6A is equal to 750. Add those together, and we have achieved our goal of eliminating C. We're left with 4A is equal to 400. Okay. A is... What? 100. A is 100. Okay. And can I now find C? Yes. So that means I have C plus 100 is equal to 175. Therefore, C is equal to 75. Okay. So I want to go ahead and conclude because we do have a contextual problem here. So I do want to come back and say that it was 100 adult tickets. Or let's see, 100 adult and 75 child tickets sold. All right. So how do we feel about that one? Good. All right.
And this is not going to be on our
No, this is not on the quiz. Okay. Our next one. A freight train leaves Ames traveling east at a speed of 60 kilometers per hour. 2 hours later, a passenger train leaves Ames traveling in the same direction on a parallel track. at 90 kilometers per hour, at what point will the passenger train catch up to the train? Okay. How many of you enjoy these distance, rate, time problems?
No.
No.
I mean, yes.
Yes?
Kidding.
Okay. I admit, I hated them when I was your age, and then I learned how to organize the information, and once I did that, they're actually not so bad. So first thing, I'm going to get a visual of this going. Okay, we have a train. This is our freight train, and it's leaving Ames. All right, going this direction. Okay. All right, I have a passenger train. Where's the passenger train leaving from?
The same direction. The same direction, but on a parallel track.
On the parallel track. So it leaves the same place on a parallel track. What is it we're looking for?
Where they catch up.
Where they catch up. So,
But the hour is different for each of them.
okay.
Well, I guess the third. Oh.
Alrighty. So that's what we're trying to figure out. How many kilometers does it take before they are in the same place? Okay, so again, it's a distance, rate, time problem, so I always set up a distance, rate, time table. I have a freight train, I have a passenger train, and we have a distance, we have a rate, we have a time. Okay, and now I'm going to plug in the information that I know. The freight train has a rate of what? 60. Okay. The passenger train has a rate of what? 90. Okay. Question, Molly?
I have a question about the actual question. It's like when it says at what point, what does that mean? Does it just mean like the distance or the time?
It's the distance. Yeah.
Oh, okay.
At what point over here? Okay, so looking over here, do we know what that distance is?
We don't.
No. And so when we don't know what something is, we give it a variable. Okay, I'm going to go ahead and stick with distance, or the D for distance. So if the distance that the freight train travels is D, what does that mean the distance for the passenger train is? Distance. Well, look. What did we say? We're trying to figure out when they both get here. Is this any different from this? No. It's the same distance. All right. Let's look at the time now. Okay. One train left 2 hours after the other.
So, well, do we know which one?
The passenger train left 2 hours after.
So we should be like H and then
X plus 2.
2X and
Or D. Isn't it? No, T plus 2 and T plus 2.
Or T plus 2.
Yeah.
Okay, let's try that and let's think about this. If I do T here and T plus 2, what does this mean?
The first one.
Okay.
Oh, yeah, because wait.
Yes.
Oh, yeah, the freight train.
The freight train is traveling.
It's the train of
The freight train travels for 2 hours longer. Now, could we also do T for the freight train and T minus 2 for... Yes,
Wait, why
both
would it
of those
travel
will work.
longer?
Because it left.
It left earlier.
But it's going slower.
Mm-hmm. Okay. Now, from this, what do we know? What is the relationship between distance, rate, and time?
It will help you find out where the point is.
Rate plus time equals distance.
Is it rate plus time?
Time.
Okay.
Plus minus.
Okay. All right. So, and these questions don't go away. These pop up all over the place. So, I'm going to ask you this. I know most of you don't drive yet, but you understand about driving speeds. Okay. What is this? What unit of speed do we drive with here? Miles per hour. Okay, so let's talk about it's a rate, yes? So the rate that we drive here is miles per hour. Okay, let's talk about this. What is miles a measure of?
Distance.
It's a measure of distance.
Wow.
Okay, so that means while rate is equal to distance over time, what does distance equal? Rate times time. Distance equals rate times time. Okay, why did I go through all this with you?
Because then we can solve
So
it.
we can understand. What
Okay, yeah. You guys know what a speed is. You know what a rate is. So don't get caught up on like that equation like, oh wait, what is it? It's distance equals. Think about the things you know. Use the things you know, okay? All right, so distance equals rate times time. So now what I'm going to do is create two equations from the table that I've created. So from my first one, we get distance is equal to 60 times t plus 2. And from the second one, I'm going to get distance is equal to 90t. All right, was it essential that I put the parentheses around the t plus 2?
Because it'll give us the 60. You have to distribute to T2 and,
Yes.
and the 2 and whatever.
Okay. Alrighty. How many unknowns do we have? 2. How many equations do we have? 2. How do you want to solve this system? What do you think, Jane?
Well, you have to have two different equations. Wait, first, how did you get from d equals 60 times t plus 2?
I just went straight across my table here.
Oh, wait.
Distance, rate, time. And this one is the next line, the distance, rate, time. I just went straight out of the table.
Distribute it, and then I thought that somehow you got to 90t.
Oh, no. I just created the two equations. What do you think, Stella?
Do you like distribute it first and then set it up so that you can either substitute or
Okay, yep, we can distribute. Okay, so if we distribute the first equation, we end up with d is equal to 60t plus 120. Our second equation is still d equals 90t.
I think we should do substitution.
Okay, what are we going to substitute here?
We need to.
D. They're both D.
God!
90T equals
They're both D. Okay. So, take that D there. I'm going to replace this D with this D, which is 90t. 90t is equal to 60t plus 120. Yep. 30t equals 120. What does t equal? T is equal to 4. Okay, so that means we know that the passenger train traveled for how many hours?
4.
How long did the freight train travel?
6.
6. What is the distance? What do we want to plug into?
90.
The 90. That's the easy one. D is equal to 90 times 4. So, how many miles or kilometers in this case? Yes. 360 kilometers later, they meet.
Okay. You're so smart.
Okay. And now what do we think of our distance, rate, time problems?
That one got fun.
Okay.
I like it.
All right.
It was fun to do together.
Yeah, it was fun to do together. Let's see what happens.
All right. This next one's fun too. Okay. Let's look at this one. A motorboat traveling with the current can go 24 miles in 2 hours. Against the current, it takes 3 hours to go the same direction. Find the rate of the motorboat in calm water and the rate of the current. So, what are the two things we're trying to find?
The rate of the
motorboat
and the rate of the current.
Okay, there's two rates we need to find here. Okay, so again, it's a distance, rate, time problem, so I always set up a table.
Oh yeah.
I promise you, the table is so helpful. So distance, rate, time. We have two situations. What are the two situations?
A motorboat traveling With the current.
With the
and
current.
Without the current. Against the current.
So we have
Yes.
with and against.
Yes, Allison.
Okay. What is the distance with?
24 miles.
24.
And the time is 2 hours.
And the time is 2 hours. Okay. What is the distance against?
24.
24
3 hours.
in 3 hours. Okay. Now, we said there are 2 rates that we're looking for. So let's think about this. How many of you tubed down a river?
I have.
You have? Okay. So if you're floating, how fast can you go?
Just the current.
As, whatever the current is. You have the equation?
Well, can't we do R equals G over T?
Okay, you can do that, and that'll give you the average rate, but we need to find the rate of the current and the rate of the boat. So remember we have 2 rates we're trying to find here. Not just one.
So
Okay.
rate for rate, are we gonna have 2 equations?
Not 2 equations. So remember, like you said, if you're just floating, you go the rate of the current. What if you're swimming with the current? How fast are you going?
You might go
How fast you're going?
How fast are you going?
Swimming.
What- Okay, whatever you happen to be going plus the rate of the current. Okay, so that means when we're going with, we're going to call the rate of the motorboat, let's just call it B for the boat and C for the current.
Oh, okay.
Okay, so whatever the boat is going plus the current that's pushing it along.
Then would the other one be
B minus C?
B minus C. Because now you're pushing against the current. Okay, so I want to warn you here, be careful with these. Students often flip that and try to put the current first. And if you try to do current minus the rate of the vehicle or whatever happens to be going, in this case the boat, it's not going to work. Yes, you're going to get a really messed up solution, and then you'll be all frustrated. Okay, so remember, it's whatever the rate of the vehicle is minus the current. Okay, we've already established distance equals rate times time. So what is the first equation for width? 24 equals B plus C times
Would you just
times 2. Okay, B plus C. Remember that rate is one single term, so we've got to put the parentheses around the B plus C. All right, what's my next equation?
24 equals B minus C. And parentheses times 3.
Okay. Do we see multiple ways to solve this 2-variable system? Okay.
Yeah, we can do a little.
Okay. So before we eliminate, though,
We have to distribute, right?
well, what happens if we just divide each of them
Oh.
first? What if we divide this one by 2? What do we get?
12
12 equals B plus C. What do we get for this one?
8
8 equals
B minus.
B minus C. Oh, doesn't that eliminate beautifully?
Yes, that's so nice. That's so nice.
Oh, I
It's
kinda
gone.
love that.
Okay.
I do love that.
So we get 24.
4 equals B.
No, that's not 24. What am I doing?
Wait.
I mean, 20 equals
I can't add. 20 is equal to
2B.
2B. 1B is equal to 10. What does B represent?
The boat.
The boat.
The rate of the boat. And now how are we going to find the rate of the current? Plug it in. Okay, so if I do, or I'll just do this one, 12 is equal to B plus C. 12 is equal to 10 plus C. C is equal to 2. So the boat travels at what rate? 10 what?
10 miles per hour.
Miles per hour. It's a rate. And the current is traveling at 2 miles per hour.
Yay. I
Okay.
like that one better.
All right.
Yes, way to have
Okay. So we're going to take all of this and we are going to add on to it. We're going to bring in a third variable. Okay. So now we're going to get into a 3-variable system. Okay, so there's only a little bit of extra work at the beginning for a 3-variable system. So the difference is, with a 2-variable system, you're just looking at 2 lines. On a 3-variable system, they're not lines anymore, they're planes. Okay, so what do we mean by a plane?
Oh, like this,
Yes.
like this plane.
Yes.
And then this plane.
Yes, like a sheet
And
of
like the
paper.
ones that can
Yes.
go diagonally.
Yes.
Oh.
Okay. So when we think about that, again,
Oh, I remember.
See?
remember
The
these?
ones that can go diagonally, that's what I was
Okay. So in the first image, are all 3 of those planes intersecting together?
Yes.
Okay, but what happens when they intersect? What are they forming? They're forming a line. So if they form a line, how many solutions is that one going to have?
Infinite.
Yes, this is infinite solutions.
Where?
Do we have to draw this like?
No.
Because I'm
These are where the infinite solutions are because the line goes on forever.
Okay.
Okay. All right. Let's look at the next one. Where do all 3 planes intersect all together? At this one spot here. How many solutions is this? It's one solution.
Wait.
Well,
I have a question.
Yes.
Okay. Okay. So was the dot there? Did we have to know to put it there, or was it there with the problem?
It was there with the problem. So I
well,
was
if the
pointing
dot-
it out.
If the dot wasn't there,
Mhm.
what would?
Well, you would look here and you'd see that's the only spot where all 3 are touching one another. They all 3 have to touch. Okay.
But wouldn't you know that on the other side too they would touch? And on
They
the other
do,
side-
but it's the same point. It's the exact same point. Yeah. So this is getting into 3 dimensions. If you rotate it around, you'll see it's the same spot. It's like, well, the wall has a thickness, but the corner down there, that's where this wall meets, that wall meets, and the floor. So there's 3 planes that intersect at that one corner. Right? So even if we went on the other side, and we said hypothetically that this wall continued forever, it's the same corner, same exact spot. Okay. Now we have the situation down here. What's going on in the first one?
They don't.
Okay. Okay. 2 touch at a time, but all 3 never touch all at once. So it's a no solution. Okay, it's the same thing in the second image. These 2, yes, they are intersecting. These 2 intersect, but there's no place where all 3 intersect. Yes, and the last one, because those planes are all parallel. That's like our ceiling, our floor, and the floor downstairs. Yes, these are all no solution. No solutions. Okay. Because only 2 intersect here. Yes, they all 3 have to intersect.
So why is it? Sorry, I'm so sorry. Why is it one? Then because I'll take you.
Well, like this 2, only 2 intersect here. Only 2 intersect here. They all, yes, they all 3 have to be touching one another. All 3 together. Okay. Oh, you're good. Okay. Yes, Molly?
If you had like those like parallel and they were kind of like angled together, so like at some point they would probably touch.
Uh-huh.
Would that have a solution?
Yes.
If it didn't like show that intersection.
Yeah, then they would have to, they'd have to not be parallel.
Yeah.
Yeah, if they're not parallel, they are,
Like if they're not parallel, but you can't like see them touch. Like if it's just.
yeah, because theoretically they go on forever. So there would be some place that they would. Okay. I'm not going to read through these instructions because doing it is kind of the best way. But just so that you know, If you need a reminder of the steps, they're written for you, but we're about to go through them, and it works better that way. So the 3 variable solutions are very much like the 2 variable solutions. If you get a false statement like 0 equals 1, what does that tell you?
That goes.
No solution. It's a false statement. If you get a true statement like 0 equals 0, that is a true statement, which means how many solutions?
1.
Just 1?
Infinite.
Infinite. That's going to be infinite. Okay, so it's the same thing. All right. So we're going to sort of burn through a few examples here. When you are solving 3 variable systems, don't ever just jump in. There's not like a set of rules to follow. Kind of take a step back and look at the whole system and think about what you can do easily. Okay. What do you see, Caraday?
You can plug the 3 into z on the equation above it to find y.
Exactly. Right. So I always number mine off. 1, 2, 3. Okay, and then we can see z is already solved for us, so we're going to plug z equals 3 into equation 2. So that gives us y minus 3 times 3 equals negative 7, which is y minus 9 equals negative 7, and y is equal to 2. So now we know what z is, we know what y is. The only thing left to find is x. And to find x, we have to go to the first equation. All right, so using equation 1 now. We don't know x. 4 plus y is 2, plus z is 3 equals 12. X plus 8 plus 3 is equal to 12. What does x equal? 1. Okay, so remember when we did systems of 2 equations, the answer, the solution was the ordered pair, x, y. Okay, this is an ordered triplet. Okay, now it's x, y, z, so x goes first, y goes second, and then z at the end, and there is our solution. Yes?
If it's fairly close to like x and y, so would you do it? If it's like a, like p, and like r, would you just do like alphabetical?
Unless you had a context to it, and then you would just state what each of them represents. Okay. All right, we're going to do elimination with this one because it's a little more involved. Okay. All right, so again, always kind of step back and look to see which variable would be easy to eliminate.
The y in the second equation.
The y in the second one because it has a negative. And what do we see in the first equation?
2y.
Positive 2. That's a really low common multiple. All right, so that means, and again, I always number these off. Equation 1, equation 2, equation 3. What do I have to multiply equation 2 by?
2.
2. So, and I always keep track of what I'm doing in case I need to backtrack if I made an arithmetic mistake somewhere. So I'm doing 2 times equation 2. So that's 2 times 2x, that's 4x. 2 times negative y, that's minus 2y. 2 times 3z, that's plus 6z, and 2 times 4 is 8. And to that, I'm going to add equation 1. So I'm just going to rewrite equation 1 underneath to keep everything straight. And adding those together, 4x plus 3x is 7x. We've eliminated y, remember that was our goal, plus 10z is equal to 19. I'm going to now label this equation 4. Okay.
I remember.
Yes. Alrighty. Now, we've only used equation 1 and 2. We have to use equation 3 this time. Okay? And we have to eliminate the exact same variable or we'll go in circles. Okay?
So let's do 2.
So, yeah, and then it's your choice. Once we've pulled equation 3 in, you can pick equation 1 or 2 to work with. So which one would be the easier one? 2 is going to be the easier one. What do I have to multiply by equation 2 by in order to eliminate? Just 3?
-3.
I would have to use -3. So I'm going to do -3 times equation 2. Okay, so that gives us -6x plus 3y minus 9z is equal to -12. And to that, I'm going to add equation 3 because we had to use equation 3 now. So just repeating equation 3, 5x minus 3y plus 5z is equal to -1. Add these together, we get -x. We've eliminated y. Again, that was our goal, so yay us. And minus 4z is equal to -13. And I'm now going to call this equation 5. Because what did we do now? Now that we have equation 4 and equation 5, what are they?
We only have 2 equations now.
It's
We
two
only have
variable
2
system.
variables.
Do you already know how to solve a 2 variable
Yes.
system? Yes, you do. So at this point, we just do everything that we just did solving 2 variables. We can use substitution, elimination. What do you guys want to do? You want to substitute? Okay. What do you want to isolate?
We isolate negative x.
You want to, okay, I'm going to isolate x, not negative x. Okay. So I'm going to move my x to this side here. X is equal to, this will give us 13 minus 4z. Okay. And so let me put a note. 4 and 5 are now a 2 variable system. Okay, I've isolated x.
Why did we make a note?
What's that?
Well, do we have to make the note?
No, you don't. I just wanted to make sure that everybody realized what we did. Okay. Alrighty. So now I can plug this x into, which should I plug it into?
X on the other one. System
On
4.
equation 4, yes. Into equation 4. So I do 7 times 13 minus 4z plus 10z is equal to 19. Alrighty, what's that going to be? It's 91 minus 4z plus 10z is equal to 19.
28.
Thank you. I just thought I would make it today without making a silly mistake. 28z. Okay. Alrighty, so that's going to give us, that's going to be a negative 18z. I'm going to move it to the other side, so I have a positive 18z. And on the left side, we get, is that 72?
Wouldn't you add them together? Because
Yeah, so negative 28z plus 10z is negative 18z.
when you move the 18 on and you move the 19 back on, it would be 91 minus negative 19.
Well, no, it's a positive 19. So, yeah, the opposite would just be minus.
72.
All right, so what does that mean z is?
72 divided by
4. Z is equal to 4. All right, what should we go back and find now?
X.
We should go find x now because we have x isolated here already. So x is equal to 13 minus 4 times 4. So what does x equal?
-3.
-3. Okay, now we have x, we have z. The only thing left to find is y. Where are we going to plug in to find y?
One of our first.
One of the original. Which one's the easiest?
Oh,
Probably 2. Question, Jane?
So I was still working on getting z equal to 4. So where did you do the part where you found x?
Oh, I came back to this one here,
Okay.
and then I just plugged in the 4z into this one.
Okay.
Okay, so in the end now, I'm going to use equation 2 because that's the easiest. So we get 2x minus, oh wait, no, we have x. We don't have y. So 2 times negative 3 minus y plus 3 times 4 is equal to 4. So that's negative 6 minus y plus 12 is equal to 4. So that's y is equal to 2. And how should I write my answer?
You should like negative 3, 2,
Negative 3, 2, 4. That's it. Okay, so I'm going to talk you through this one really quickly, and then I want to do the application problem with you quickly. Okay, so again, always take a step back and see if you notice anything about this one. What's that? Yeah. Anything stand out to you? What? Nancy.
Equation 1 and equation 3, you just have to minus 2.
If you straightforward, just subtract, or what would you need to do first? Well, so remember, if you want to eliminate, you have to have the same coefficient.
You just have to make equation 1 negative.
Yeah, or make equation 3 negative.
Just multiply the whole thing by negative 1.
Okay, so you're saying equation 1 and equation 3? Does anybody see anything?
Oh,
Anything else that stands out to you, though,
equation
before
1
we do
doesn't
that?
have any like valid
Okay.
coefficient. Oh no.
Well,
Except
what is the coefficient,
It's
actually?
one.
It's 1.
But-
And it's 1, 1, 1. Do you see it now?
Yes, you just well, I think that you can multiply equation 1 by negative 5, and then you plus.
Yeah, Molly's like, yes, right?
yes.
Yes. Pay attention to things like that, because you could have spent a lot of time eliminating just to find out
Wait.
what's going on with this one.
But there's no solution because 2 doesn't equal 3.
Yes, because if you multiply all of equation 1,
Okay, that
let
makes
me
sense.
change colors here, by negative 5,
Wait, no, it's not.
all right, you end up getting negative 5x minus 5y minus 5z equals negative 10. And when you add that to 5x plus 5y plus 5z equals 3, well, we get something, but what do we get?
You get 0 equals negative 7.
0 equals, yeah, that's false. Therefore, once you get a false statement,
The whole thing is no solution.
no solution.
Bro.
So this is what I mean. Always take a step back and see, like, look for things like that that might keep you from doing a lot of extra work. Okay, so we have 5 minutes left. I'm going to not run through these. I'm going to run through. There's a lot of extra practice. The PDF of this is already posted. The answers are on there, so if you want extra practice, you can check the answers. But let's do this application problem. Alrighty. We have a photo album with 80 pictures. Each picture is in the shape of a square, rectangle, or circle. 12 times as many rectangles as circles, 10 more squares than circles. How many of each type of pictures in the photo? So, again, we are looking at the types of pictures and how many. So I'm going to let S equal the number of square pictures. I'm going to let R equal the number of rectangular pictures. And I'm going to let C equal the number of circular pictures. So, 3 variables. How many equations do I need? 3. Okay, so coming into the text, I notice there's a total of 80 pictures. What kind of equation can we create from that?
S plus R plus C equals C.
All right, 1 equation down, 2 to go. What else do we see?
12 and 10.
See, let's see.
C plus Y equals rectangles.
Okay. Okay. Okay, so I heard C is equal to 12R. Okay, let's think about this statement here. 12 times as many rectangles as circles. Which one should you have more of? Should have more rectangles.
Rectangles equals 12.
Yes, it's rectangles. Be very, very careful when you are doing these when there's a times involved. This is probably the most common mistake with this is putting that multiplication on the wrong side. So set it up and ask yourself, is this giving me what the statement is saying? You know, which one should I have more of? All right, and so you guys told me you should have more rectangles. Well, that didn't match this equation. Okay, so now we have r is equal to 12c. What's our other one? S is equal to c plus 10. Alrighty, is this a pretty easy system to solve? Yes, all right, we can substitute everything in. S is c plus 10. Yep. R is 12c. C is just c. All of that should add up to 80. So I have 12, 13, 14c plus 10 equals 80, which means 14c is equal to 70, so c is 5. Okay, which means what does S make? 15. And what would R be? R is 60. Okay, so in the end, we have 15 square, 60 rectangle, and 5 circle pictures. Yeah, the problem with this one is it comes in the setup, okay? Because had we not caught that mistake with the R and the C, it would have been pretty messy. Okay, so